Students, good morning. Today we'll continue nuclear chemistry class. Okay, so this is the sixth class. So in the previous class you are well familiar about the nuclear instability and referring to the number of neutron to number of proton ratio, that is n by p ratio graph, and also with referring to the binding energy per nucleon versus atomic mass number. Even in that graph you have referred to graphs, and in both you are well familiar when the nucleus is stable and under what conditions the nucleus becomes unstable and how it changes to attain the stable state. Okay, so in addition to it, one more factor is there, that is magic number of nucleons. So any element or the atom of an element, if it is having number of protons as 2, 8, 20, 50, 82 or 114, or the atom of an element if it is having number of neutrons as 2, 8, 20, 50, 82, 126 or 184. Such nuclei are said to be stable nuclei. See, that means this number indicates, or the atoms of an element with these numbers, they are quite stable because they have completely filled nuclear shells. That means the nuclei which are having such a magic numbers, they are quite stable because with this number of either protons or neutrons, their nuclear shells are completely filled state. Hence, they are quite stable. And also, in addition to it, also there are many number of isotopes which are stable. Say, the 157 isotopes are found stable which are having even number of proton and even number of neutrons. Similarly, there are 53 elements or isotopes which are having even number of proton and odd number of neutrons, and 50 isotopes which are having odd number of protons and even number of neutrons, and there are 5 elements or isotopes of an element which are having odd number of proton and odd number of neutrons. Okay, so now say the magic number, for example the tin, the symbol is Sn, say atomic number is 50, so it is having 50 proton, and say with that the tin is found to be more stable compared to indium. So where it is atomic number is 49 and it is less stable, or it is having less number of isotopes which are stable, and tin is having more number of isotopes, all isotopes are stable. So therefore such numbers are said to be magic numbers, and even with this we can predict, or we can say specify the elements whether they are stable or why they are stable. Okay, and now the stable elements are abundant in nature. The stable elements are abundant in nature. Okay, they are quite stable. Okay, now with this we'll move on to the next one, that is decay process. Decay process or disintegration process. So far you are well familiar with the stability of nucleus. Okay, so now under this, say decay process is nothing but when an unstable atom undergoes or loses energy by radiation. So an unstable atomic nucleus loses energy by radiation, and such nuclei are said to be radioactive element. And three of the most common types of decay are alpha decay, beta decay, gamma decay, or alpha emission, beta emission and gamma emission. They are most common, and they are also sometimes involved the emission of photons. Okay, and gamma emits, along with that photon is also emitted. Now see the unstable atomic nucleus when it emits such radiations, and this will be continued till it reaches stable state. Therefore, decay process, we can say an unstable nucleus undergo slow spontaneous emission of, say, energy particles or the radiations like alpha, beta, gamma, etc. to reach the stable state. Okay. So now with this, suppose an element emits alpha radiation, then the resulting atom or the element is having, say, atomic number is having decrease in atomic number by 2 units and the mass number by 4 units. Say here X stands for an element ZA. When it emits alpha radiation, then the X will have Z minus 2 atomic number, A minus 4 mass number. You can take the example polonium 84 215. When it emits alpha radiation, the resulting element is lead with 82 211. Okay, so suppose the element emits, say, beta radiations, then there is an increase in atomic number by 1 unit and there is no change in mass number. For example, here say X, when it emits radiation, the Z will increase by 1 unit but A remains the same. We can give the example sodium 1124. When it emits beta radiation, it becomes magnesium. So okay, now when the element unstable nucleus emits photon or say gamma radiations, there is no change in either atomic number or atomic mass number, but the energy, there is a change in energy and it attains the stable isotope. Okay, so now this is about the say decay process or disintegration process, and during the emission of say such radiations, the parent element is the beginning one, and after the emission of particular radiations, the resulting element is said to be a daughter element. Okay, so now this is about the decay process and we'll discuss in the next class.